say you want to go to school from your house. So there are 3 roads connecting your house to your school. So which route should you take? Well, let us consider your house as a point H and school as a point S. So we have these 2 points, point H and point S. Now what is the distance between these 2 points? There can be many possible paths between point H and point S. This is one path. This could be another path. This could be another path. This is another path. So what should we take as the distance between H and S? There could be many more possibilities. Well, we take the line segment joining point H and point S as the distance between these 2 points. So this line segment joining H and S, the length of this line segment gives the distance between H and S. It is also the shortest path between H and S. So the length of the shortest path between 2 points is given by the line segment joining these 2 points. So now can you tell me which route should you take? Well, the straight line joining your home to your school gives the shortest path from your home to school. So you should take this route. So this is the shortest path from home to school, and the distance between your home to school is given by the length of this path. Now say you want to go to any point on the street from your home. So these are the 3 roads connecting the street to your home. Which route should you take? Consider your home to be a point P and the street to be a line segment AB. So we can go from P to AB in a number of ways. This line segment connects P to AB. This line segment, we have this line segment. So we see that there are many possibilities. But what should be the distance between point P and line segment AB? We need a unique value for that. And that is given by the perpendicular distance from point P to line segment AB. So this is taken as the distance between the point P and line segment AB. This is also the shortest path between point P and line segment AB. So this distance is the shortest path between P and AB. So if we need to find the distance between a point and a line segment, we draw a perpendicular from the point to the line segment. It gives the distance between the point and the line segment, and it also denotes the shortest path from the point to the line segment. So now can you say which route should you take? Well, if we see, this route is perpendicular to the street. So we should take this route as it is the shortest path from your home to the street. Now we have these 2 streets. Consider them to be 2 lines. What is the distance between these 2 lines? Distance between 2 lines is the minimum distance between 2 points on these lines. If you observe, these are intersecting lines. So if we extend them, these lines will intersect. We see that these lines intersect at this point. So the minimum distance between these 2 lines is 0 because these lines intersect at this point. So this is the common point of both the lines. And at this point, the distance between the two lines is 0. So the distance between two intersecting lines is always 0. And that is why we generally do not talk about distance between two intersecting lines. We only talk about the distance between two non-intersecting lines. So here we have two non-intersecting streets. Now you need to go from this street to this street. These are the 3 lanes connecting these two streets. So which one should you take? Consider each street to be a line. So these are two non-intersecting lines. We need to find the distance between these two lines. Now the distance between two lines is the minimum distance between 2 points on the lines. So we take a point on this line. Now we need to find the distance between this point and this line. But we already know that the distance between a point and a line is given by the perpendicular from that point to the line. So this is the distance between these two lines. This distance is also the shortest path between these two lines. So this is the shortest path between these two lines, and the length of this path gives the distance between these two lines. Now I may take a point on this line. Again, I need to drop a perpendicular from here to here. So this is the distance between the two lines. It is also the shortest path between these two lines. If you note, this distance is the same as this distance. The length of these two paths are the same. In fact, you may take any point and drop a perpendicular. This length remains constant. So this length remains constant. So distance between two non-intersecting lines is constant at all points. We take any point on any line and drop a perpendicular to the other line. The length of the path will remain constant at all points. So now can you tell me which route should you take? Well, we see that this lane is perpendicular to the street. So we should take this lane as it is the shortest path between these two streets. In fact, there can be many possible routes, and you have to travel the same distance in each of these lanes. So till now, we had learned that parallel lines are the non-intersecting lines. But another way of defining parallel lines is that distance between them is constant at all points. So this is another way of defining parallel lines. Distance between them is constant at all points. Take a point on one of the lines, drop a perpendicular to the other line, and do this for as many points as you want on any of the lines. The distance remains constant. So this is how we define parallel lines. So can you tell me, are these lines parallel or not? Well, they do not appear to be parallel. Let us draw these lines. Let us draw lines here. So I draw lines. In this way, we draw lines all over. So we can see these lines. Now let's just concentrate on the lines. So take any two lines. We see that this distance is constant. This distance is the same. which means that these lines are actually parallel. Although these did not appear to be parallel, but these lines are actually parallel lines.